EEE EC 201 Electrical Circuits 1. In today's lecture, we will study some of the basic circuit theorems, namely superposition theorem, Thevenin theorem, Norton's theorem. We will study these theorems using both dependent and independent sources. Superposition theorem. This theorem states that the current through or voltage across any element of a network is equal to the algebraic sum of the currents or voltages produced independently by each source. In other words, if there are multiple sources in a given network, then we can determine the resultant current or potential drop across a particular element by determining the effect of only one source at a time and keeping all the other sources deactivated during that point of time. Now, deactivating a voltage source is basically replacing it with a short circuit equivalent. And deactivating a current source is replacing it with an open circuit equivalent. The concept will become easier for you to understand once we solve these problems. Problem 1. Use the superposition theorem to find V in the given circuit. So, over here, if you see this network, for this network, we have to determine V, which is the resultant voltage across the 4 ohm resistor. This network has two sources. One, the 6 volt voltage source, and the other one, the 3 ampere current source. Both of them are independent sources. Now, in order to determine the resultant voltage across the 4 ohm resistor, we need to determine the effect of each of these sources on this particular resistor. In order to do that, we have to keep only one source active at one particular time. At first, I have considered to deactivate the current source. Deactivating the current source is replacing it with an open circuit equivalent as shown over here. So, if we deactivate the current source at first, this is the network which we will get. In this network, if we apply KVL, then we can easily determine the current flowing through this loop. If we know the current, then we can easily determine the voltage drop across this resistor. You can also determine the voltage drop by directly using the voltage division rule. In both the cases, the answer will be the same. That is, V1 will be equal to 2 volt when the 6 volt voltage source is active. The next step is to deactivate the voltage source and activate the current source. Deactivating the voltage source is replacing it with a short circuit equivalent as shown over here. Now, using the current division rule, we can easily determine the current flowing through the 4 ohm resistor. Then, using Ohm's law, we can determine the voltage drop across the 4 ohm resistor, which will be equal to 8 volt. Since the polarity of both V1 and V2 are in the same direction, or since V1 and V2 have the same polarity, thus the resultant voltage across the 4 ohm resistor V will be equal to the summation of V1 plus V2, which is equal to 10 volts. Problem 2. Using the superposition theorem, determine the current through the 12 ohm resistor. So, for this particular network, we need to determine the resultant current I2 flowing through R2. This network has two independent voltage sources, E1 and E2. So, we need to determine the effect of each of these sources on R2 at one particular time. At first, let us consider that we will deactivate E2 and keep E1 activated. If we do that, then the resulting network will be this one, where E2 will be replaced by a short circuit equivalent. Now, in order to determine the current flowing through R2 due to E1, we need to determine the source current Is. In order to determine the source current, we need to determine the total resistance RT faced by E1. The total resistance RT faced by E1 will be 27 ohm. Using Ohm's law, we can then easily determine the source current, which is equal to 2 ampere. Now, since we know the source current Is, we know that Is will branch out in two different branches, which is this one and this two. Using current division rule, we can easily determine I2 prime. I2 prime will be equal to 0.5 ampere. The next step will be to deactivate E1 and keep E2 activated. The resulting network will be this, where E1 will be replaced with a short circuit equivalent. In the same manner, we can determine the source current for E2, and in order to do that, we need to determine the total resistance faced by E2. In this case, RT will be equal to 12 ohm. Again, using Ohm's law, we can determine the source current due to E2, which will be 48 divided by 12. The source current due to E2 will be equal to 4 ampere. Then again, using the current divider rule, we can determine the current flowing through R2, which will be equal to 2.67 ampere. Now, if you observe carefully, the direction of I2 prime is in this way and the direction of I2 double prime is in this way. So, the currents are basically flowing in opposite direction. Hence, the resultant current I2 will be equal to I2 double prime minus I2 prime, which will be equal to 2.17 ampere. Problem 3. Find I0 in the given circuit using superposition. This network has three sources: an independent current source, an independent voltage source, and a dependent voltage source. In the previous examples, when we were dealing with the independent sources, we could easily keep one of the sources active and deactivate all the other sources. But in this case, we cannot do that because we have a dependent voltage source involved. Now, from the knowledge of superposition, we can say that I0 will be equal to I0 prime plus I0 double prime. That is, I0 will be the current due to the 4 ampere current source and I0 double prime will be the current due to the 20 volt voltage source. In order to obtain I0 prime, we first turn off the 20 volt source so that we have the circuit as shown over here. This network has three complete loops. Thus, we can easily apply mesh analysis in order to obtain I0 prime. On applying mesh analysis, there will be three linear equations. One for loop 1, the second equation for loop 2, and the third equation for loop 3. If we solve these three linear equations, then we can easily determine the value of I0 prime, which will be equal to 52 by 17 ampere. Now, the next step will involve the deactivation of the current source and the activation of the independent voltage source. If we do so, this is the network which we will get. Over here, there are two loops. Hence, by applying KVL or mesh analysis, we can easily determine the value of I0 double prime, which will be 60 minus 60 by 17 ampere. Hence, the resultant value of I0 will be minus 8 by 17 ampere. The next theorem to be introduced is known as Thevenin's theorem. This theorem permits the reduction of a complex network to a simpler form.